Hello everyone, welcome back to second lecture of week 12. This is the last week as we had already mentioned in the first lecture. And in the first lecture we had explored vertical asymptotes, basically the definition of asymptotes, and the focus was on vertical asymptotes where we have seen that curve may have one or two vertical asymptotes or three, and depending on how the curve given it, right? So, here we will going to explore horizontal asymptotes as well as oblique or slant asymptotes. So, this will be a very important topic in calculus, and in particular asymptotes and the curve tracing, right. So, let us start with horizontal asymptote first. As we have already done in a first lecture, vertical asymptotes which are parallel to the y-axis. Similarly, this horizontal asymptote is nothing but an asymptote which is parallel to the x-axis. And how we can find out that one? Obviously, we have to find out something y equal to some constant, because asymptote are the straight lines, right? So, y equal to something, y equal to c1, y equal to mx, I mean c2, c3 and so on. So, that will makes the whole thing as a horizontal asymptote for that curve, right. So, a line y equal to, this is y equal to b, is said to be horizontal asymptote or asymptote parallel to the x-axis for the curve function f if fx tends to b, the whole fx tends to b, x tends to infinity or x tends to minus infinity. Now, in the previously where you have vertical asymptotes, and what you had learned? You had learned that fx tends to infinity when x tends to 0, x tends to some constant b. Here it is a different thing. Here what we are saying? We are saying that if y tends to b, y, that means y means fx tends to b as x tends to infinity or minus infinity. That's, you have to remember this one, right. And it is quite easy to look at here. Look at here. If this y tends to b here, and the whole curve tends to where? The whole curve tends to some constant, and when it will happen? When this x is going to be infinity, this x is going to be infinity, the curve is going to be some constant. That's what the idea is. Now, find out the horizontal asymptote for a function fx equal to 1 by x. Now, look at the equations. What it says? It says fx equal to 1 by x. When it will becomes the infinity or some if x tends to infinity, what will be the f of x? F of x tends to 0. So, that f of x is equal to nothing but y. So, y equal to 0 will be our asymptotes, our horizontal asymptote. So, x axis become our horizontal asymptote for fx equal to 1 by x. Method, some of the method are recommended when the function is in the px by qx, that means in the rational form. And let me remind those method for you, so that it will become easier to find out or to guess which one will become a horizontal asymptote for our given functions, right. So, horizontal asymptotes are located where the curve approaches a constant value b as x approaches infinity or minus infinity. So, if fx is given such that a x by power m plus of a 2 of something and so on divided by b x by power n. So, look at the indices here, x by power m and x by power n. These are the two indices. Now, we are going to compare it first, and then we will derive our required result in a simpler form. So, if m is less than n, that means you have x by power m something this, and you have a b x by power n, and if this m is less than bn, that means something like 2x square plus of x plus 1 divided by x cube minus of x square plus of x minus of 2 or plus of 2, right. So, what it happen? in the denominator, the power or indices of x is much greater than the indices of the x of the numerator, then the horizontal asymptote is y equal to 0. Now, in the previous example, you can see here 1 by fx is given, fx is equal to 1 by x, right? And how I have to derive that one? That can be written as x to the power 0 by x to the power 1. So, here n equal to 1 and m equal to 0. So, m is less than n. So, in that case y equal to 0 will simply become it is the horizontal asymptote for that function. So, remember this one, m is less than 1, that means y equal to 0 will be your horizontal asymptote. Similarly, if m equal to n, then y equal to, you have to find out the coefficient, the ratio of the coefficients will become y equal to a by b become your required horizontal asymptote. And if m is greater than n, in such case fx does not have any horizontal asymptotes. So, these are the basic criteria for existence of horizontal asymptote for a given rational functions. Now, look at for example, and they are finding out their asymptotes, horizontal asymptotes in reality. So, here fx equal to x square minus 6x plus 7, 4x square minus 3 is given. In the numerator as well as the denominator, the indices of x are equal. So, here m equal to n, right. So, in that case I had already told you y equal to a by b, the ratio of the coefficients of the highest power of x here in the numerator as well as in the denominator will be your required horizontal asymptotes. So, that will be how much? F of x is x square minus 6x plus 7 divided by 4x square minus 3. So, you have to cancel it out, 1 minus of 6 by x plus of 7 by x square divided by 4 minus of 3 by x square, right. So, 1 beta 4 is going to be y equal to 1 by 4 is going to be your horizontal required horizontal asymptotes, and as you can see here 1 by 4 is going to be our asymptotes, right. And how I have looking for this, because limit x tends to infinity fx, I had checked that one, and that will be equal to plus minus infinity, right. So, y equal to 1 by 4 will become our required horizontal asymptote. Example 2, look at this example, and 5x cube minus 2x square minus 7 divided by so on. So, what is the m? M equal to 3 and n equal to 3 as well. So, here m equal to n. So, y equal to a by b will be our horizontal asymptotes, right. So, these are the two coefficients. So, you make this one as a horizontal asymptotes directly. Now, look at example this 3. So, this will say x minus 6 divided by x square minus 7x plus 1. How much the m here? So, m equal to 1, and how much the m here? N equal to 2. So, here m is less than n, and in that case you had already have the results, right. When m is less than n, it is always y equal to 0 will be one of the horizontal asymptotes, remember that one always. So, that means without any calculation I can say that horizontal asymptote exists, and that is equal to y equal to 0. So, these are the practical questions, and we will look for each one of them to find out how I can do that. So, the first one, 4x square plus 1 divided by 2x square minus 3. Here m equal to n, and in that case y equal to a by b. We are looking for y equal to a x to the power m plus of something divided by b x to the power n, right. And if m equal to n, y equal to a by b will be our answer. So, y equal to 4 by 2, that is equal to 2 will be our horizontal asymptotes. Similarly, look at here. Here m is equal to 3 and n equal to 2. So, m is greater than n. In that case, no horizontal asymptotes exist, right? As you can see here, the third result, see here, does not have any horizontal asymptote when nominator has the greater indices of x or power of x, right? So, this is the power of x is greater than the denominator, henceforth there is no horizontal asymptote. What is the horizontal asymptote of hx equal to 1 by x? You can just put down here 1 by x plus of 3, that can be written as 3x plus 1 divided by x, right? And here 1 by 1, that means m equal to n. So, y equal to a by b will be your answer. So, y equal to how much? 3 by 1. So, 3 y equal to 3 will be the horizontal asymptote here. Find the horizontal asymptote of jx equal to 6 minus of 5x square. Do the same thing. You will have here 6x square minus 5 divided by x square. So, these are the indices which are equal to each other. So, y equal to 6 by 1 will be your answer. Similarly, can you find out this one? So, this is going to be x square plus 1 divided by x, and m is greater than n. In that case, there is no horizontal asymptotes, right? So, I have solved all those 5 questions. You just go to clear your views and clear your concepts in this regard. Similarly, we have 6, 7 and so on. So, just go through it. Now, I have to start with the oblique asymptote. What is the oblique asymptotes? Oblique asymptote, that means it is neither parallel to the y-axis nor the parallel to the x-axis. It is in between these, that means the slant one. So, the curve is just an oblique type of things. So, if an asymptote is neither parallel to x-axis nor to y-axis, then it is called an oblique asymptote. An oblique asymptote occurs when the degree of polynomial in the numerator is greater than that of the polynomial in the denominator. To find the oblique asymptote, numerator must be divided by the denominator by using either long division or synthetic division. Remember this one. Numerator must be divided by the denominator firstly, either by long divisor and so on. So, when the degree of polynomial in the numerator is greater than that of polynomial in the denominator, then we have to divide the numerator by the denominator, and once we have, then that will be your answer. Here 2x square plus 3x plus 1 divided by x. So, divide x from here and it will gives you y equal to 2x plus 3 as an oblique asymptotes, right. So, what are the method for to obtain the oblique asymptote for a given functions? So, let us assume that y equal to mx plus c be our required oblique asymptote, and let the equation of the curve be given phi n x y plus phi n minus 1 x y plus so on phi 1 x y plus k equal to 0, right. These are the equation of the curve. So, 1 is the equation of a curve where phi n x denotes the term of the highest degree of the curve. So, whatever the highest degree of the terms are there, you just put it phi n x y, phi n minus 1 and so on. Put x equal to 1 and y equal to m. In phi n x y, you will find out one equation in m, right, because you are putting x equal to 1 here, and find all the roots of phi n m equal to 0. If m is non-repeated root, then corresponding value of c is given by c into phi n dash m plus phi n minus 1 m equal to 0, and where phi n dash m is not equal to 0, right. If phi n dash m equal to 0, then there is no asymptotes, right. And if m is repeated root occurring twice, then the two values of c are given by c square by factorial 2 phi double dash of n m c by factorial 1 phi dash n minus 1 phi n minus 2 m equal to 0, and the asymptote of the curve is y equal to mx plus c. So, basically what it will tell you, let me give you one example and then come back again for this method to obtain the oblique asymptotes. Because the examples are going to simplify the method itself and maybe very clear for your concepts as well. So, in a so-so manner you can find out, you can have the one concept, that is, let us y equal to mx plus c be our oblique asymptote, and what will be the value of c? You have to obtain that one. So, let me give you one example first. So, here look at this curve, and x cube minus x square y minus xy square plus of y cube plus of 2x square minus 4y square plus 2xy plus x plus y plus 1 equal to 0. Here the highest degree of the terms in the function is 3. So, what I have to do? I have to put phi 3 xy, and this will be x cube minus of x square into y, right. So, 2 plus 1 and minus of xy square plus of y cube. These are the all terms we have here, right. Similarly, can you put phi 2 xy? So, which one? 2x square minus 4y square plus of 2xy. And do we have phi 1 xy? X plus y. And do we have phi 0 xy? We have 1. That means the constant. This means the constant. You may neglect that one. And firstly, we have to check whether the curve has the horizontal asymptote or the vertical asymptote or not. This is for the oblique asymptotes. So, in the curve, the highest degree is 3 and the coefficient is 1, equating it to 0, we get 1 equal to 0, which is absurd. It cannot be happen, and henceforth there is no asymptote parallel to the x-axis. Similarly, you can find out that the coefficient of the highest term is in y is 1, thus the curve has no asymptote parallel to the y-axis as well. So, there are no vertical or horizontal asymptote for this given curve, and we had find out phi 3 xy, phi 2 xy and phi 1 and phi 0 xy, right. Now, put y equal to m and x equal to 1. So, putting here what you obtain? You will obtain phi 3 is equal to 1 minus of m minus of m square plus of m cube, right. And what will be the phi 2? Phi 2 is equal to 2 minus of 4 m square plus of twice m, right. And phi 1 is equal to 1 plus of m. Now, our claim is that y equal to mx plus c will be its oblique asymptote, where c is unknown and m is unknown as well here. So, we had obtained this one, right. In the previously we had obtained this one, and what we have to do? We have to equate this is equal to 0. So, equating this is equal to 0, phi 3, the highest degree obtained, right. So, how many points you obtain? You obtain 3 points, m equal to 1 plus minus 1. That means this is repeated roots, 1 is the repeated root, and minus 1 is non-repeated root, right. And that means for the non-repeated root we have the one solution to find out c, that will be c into phi 3 dash m plus of phi 2 m is equal to 0. And what will be the phi 3? Phi 3 is given here. So, can I obtain phi 3 dash m? Of course, I will. So, how much the value? This will give you 0, this will be minus 1 minus 2m and plus of 3m square. This will be your answer, right. So, this will comes out 3m square minus 2m minus 1. Here the phi 3 dash m is here, right. So, 3m square minus 2m minus 1. Now, obtain phi 2m is given already. So, c into phi 3 dash m plus of phi 2m is equal to 0, This will makes you one conditions which has been obtained for C. So, C in terms of M, C in terms of M can be obtained, and this will be this one. 4m square minus 2m minus 2 divided by 3m square minus 2m minus 1. Now, what was the non-repeated root? That was m equal to minus 1. Put this value here. So, this will comes out 4 minus of, so this will be plus of 2, and this will be minus 2 divided by 3 minus minus plus 2, and this will be minus 1. So, this will be comes out to be 4, this will cancel out, and this will also comes out to be 4. So, 1. So, here we had obtained C equal to 1 for m equal to minus 1. So, y equal to mx plus c, this will become minus x plus of 1. So, that means y equal to 1 minus x will be our one of the oblique asymptote for this function. Similarly, since we have 1 as the repeated root, I will do the same thing, and this one will be our answer. And since m equal to 1 is the repeated root, I will go back to my equations, and we will have the different scenario. So, since it is the 3 times of highest degree is 3. So, we can use c square by factorial 2 into phi 3 double dash m plus of c by factorial 1 phi 2 dash plus of phi 1 equal to 0. And now phi 3 double dash will become 6m minus 2, and phi 2 m is equal to given. So, phi 2 double dash can be obtained 2 minus of 8m, and phi 1 m is given 1 plus m. Now, put all those c square by 2 6m minus 2 plus 6 into minus 8m plus 2 plus 1 plus m equal to 0, and this will, and for what will be the m? For m equal to 1 we are looking for, right. So, put the value of 1, m equal to 1. This will comes out a quadratic equation in C, c square minus 3c plus 1 equal to 0. Obtain the root c equal to 3 plus minus of square root of 5 divided by 2. So, there are two value of c, and henceforth y equal to mx plus c, and that is equal to m equal to 1. So, x plus of 3 plus root 5 by 2 is one of the oblique asymptotes, and the another one is x plus of 3 minus of root 5 divided by 2. This will be the another one, and the first one was y equal to 1 minus x. So, this will be the third one. So, all these three, as you can see here, this was the first one, this one was the second one, and this one was the third one, and these two have come for the repeated root, and this one came as the non-repeated root, right. So, as you can see, to obtain an oblique asymptotes is a very tedious job, and you have to be very careful about that. Why? The one question has been arise here, the pertinent question, that is why we are choosing c square by factorial 2 phi 3 double dash m only. Why not c3 and so on? So, for that it's totally depend on the degree of the curve. So, the degree of the curve is n, then you have to choose c n minus 1 divided by n minus 1 factorial, and then phi n minus 1 divided by phi n m, and so on. So, now with this example you now understand what the method for the oblique asymptotes is saying. So, what we have done? We have just assumed that y equal to mx plus c will be our oblique asymptote. Now, in this straight line y equal to mx plus c, m as well as c are unknowns. So, I have to obtain m first. To obtain the m first, I have to gather all the equal terms in the curve, given curve. So, let us say phi n x y, phi n minus 1 x y, and so on. and this phi nx by denote the curve, the term of the highest degree of the curve. So, and once again we had obtained that one, then put x equal to 1 and y equal to m, that will give you a phi nm as a polynomial, and equate that equal to 0, find out the roots of the phi nm, and that will be the roots, let us say C1, C2, C3 and so on. Identify which one is the repeated root, which one is non-repeated root. If you have a non-repeated root, that will be quite easy to do that. There is only one C value, C phi n dash m plus of phi n minus 1 m equal to 0, right. And if phi n dash m equal to 0, then there is no asymptote for the non-repeated roots. If you have a repeated root, then it totally depends on the what type of the degree you have. So, once you have a degree, nth degree of the term, then c square by factorial 2 plus of c by factorial 1m and phi n plus 1m, that will makes you the required value of the c in the y equal to mx plus c as an oblique asymptotes, right. So, that is what we had done, and I believe that we have done very clearly. If you do not understand, let me know, or I can go through it. So, what I have to do, I have to check first horizontal as well as the vertical asymptotes, and we find out that there is no horizontal as well as vertical asymptote here. Then what I have to done, I have to gather all the highest term or the 3 degree terms of the terms, all these are, and then we have obtained the second degree terms, right. Then we have obtained the first degree term, and this is the constant 0 degree term, and name all those phi 3, phi 2 and phi 1, and put the value x equal to 1, y equal to m. This will give me 3 polynomials in m, right, and then equating the highest degree equal to 0 will give me the value of m. With those value of m, I have to identify the repeated and non-repeated roots. 1 is the repeated root while minus 1 is non-repeated root, and therefore, for the non-repeated root I have to use the formula C phi 3 dash m plus of phi 2 m, where phi 3 dash m is not equal to 0. So, we had find out here phi 3 dash 2 m square minus 2 m minus 1, and putting m equal to minus 1 is not equal to 0, and henceforth I can obtain this C. So, what is the C? C become 1. So, y equal to mx plus c is now become m equal to minus 1 minus 1 and c equal to 1. So, y equal to 1 minus x will be our one of the oblique asymptote. Similarly, what was the repeated root? Repeated m equal to 1 is the repeated root, and henceforth I have to use this formula. I have to use this formula, right. C square by factorial 2 phi 3 double dash m plus c by factorial on phi 2 dash m and phi 1 m. Obtain all those and putting this value, this will give me c equal to 2 terms, c equal to 3 plus minus root 5 by 2, and henceforth we will put back y equal to mx plus c, and what will be the m equal to 1. So, y equal to x plus of 3 plus root 5 by 2, and y equal to x plus 3 minus root 5 by 2, and y equal to 1 minus x. All these 3 are the required asymptotes we had for this curves. So, I believe that it will clear your concept, and just go through it. What it will say? It will say that if the nominator has the more or the greater degree of the denominator, you have to firstly divide that one. So, once we have divide, what we have get? We have get x minus 4 and x plus 12, and y equal to x plus 12 will be your required asymptote. And just go through the practice questions, and I hope that you will obtain. This will be one of the trickiest concept in asymptotes. Just go through it one by one, these 2 problems for you, and I hope that you will get the better concept by doing yourself. So, thank you so much.